Thank you for that kind introduction. AI is a powerful tool, but it's critical that we design AI systems at what I term the user level, the community level, and the society level. And if you do so, I think this is how you will better ensure to create AI systems and applications that have a positive impact on society. I've been working on defining this new model for AI design over the last couple of years, and today I want to make it a little clearer to you as I speak about the need for a more human-centered view of artificial intelligence. So as you all know, AI is taking the world by storm, whether it's in scientific discovery with systems like AlphaFold, which are changing how medicine is going to be practiced in the near future, to natural language processing systems that allow us to speak to others and communicate with others and read documents all over the world, whether you're traveling or you're just trying to read comments on reviews in social media in a different language, to even AI-driven fashion design, trying to predict what the styles are going to be that are going to be popular and not waste creating things that will be thrown out quickly. But the general public has really only been introduced to this concept in the last couple of years, really with the advent of ChatGPT and similar generative AI systems. So ChatGPT to summarize a document, or even yesterday I was in here translating slides, or Midjourney and DALL-E to create an image based on a text prompt, or co-pilots helping programmers program more effectively. Now, foundation models are what powers this generative AI applications today. So these are machine learning models, and machine learning models use statistics from a large amount of data to predict an output given an input. So for generative AI, an input like, give me a fashion shoot of a woman with decaying peonies, may give us an image like the one I showed on the previous slide. These models are special in that they are trained on huge swaths of the internet. So they're huge. They require hundreds of millions of dollars in computational resources to train, and more they're trained on multiple modalities. So text, images, speech, video, and music. And the idea with the foundation model is that one very, very large model trained on a diverse set of data can be used to solve a variety of tasks. Sometimes right out of the box, and sometimes you may need to fine-tune a model with specific data needed for the task that you're trying to solve. That's why we call them foundation models. You can build applications on top of these models, these foundations, without having to train the models yourselves. This is the future of AI in our everyday lives. This is what's powering many of the applications that will be built over the next years. But I would claim that AI has been in our everyday lives for several years. A common place we see AI making impact today is in manipulating our social network feeds, causing people to feel bad, which research has shown, especially for young women on social networking applications like Instagram, or deceiving people about what is true or not and causing folks to be outraged, even upending democracies all over the world. Or we see AI helping judges to set bail or sentencing for suspected criminals in a way that is biased by race. That was so clearly described yesterday by the judge, as has been shown in the United States with the Compass system. Or we've seen AI-based chatbots hallucinating incorrect information that causes a business, in this case Air Canada, reputational harm. Because of both the benefits and potential harms of AI, we founded a new institute at Stanford, the Institute for Human-Centered AI, just over 5 years ago. And given that we saw that AI was going to impact all of society, we felt a university as an independent third party, and with all the breadth of Stanford, from AI and technology to the social sciences, to law, to business, to medicine, with strong arts and humanities as well, was the ideal place to have impact on this technology that we could shape and how it's used in the future. And so HAI's mission is to advance AI research, education, policy, and practice to improve the human condition. And because of the important positive and potential negative impacts of AI, HAI's vision from the start has been guided by 3 principles, and I'll speak briefly about each. So the first, represented by H, we should be guided by a concern for AI's impact on human society. This technology is too potent to consider its impacts and effects after the fact, compelling us to explore the ethics of AI both before, during, and after its development. Second, I'll talk about I. AI should be inspired by human intelligence. The human brain remains the most sophisticated device in the known universe, and we should strive to learn all we can from its nature. Although deep learning has really pushed this field forward in the last 10 years, we don't think that's the be-all, end-all of what intelligent machines will be like. And so we want to also understand the human brain and human behavior and how that may inspire new algorithms, as well as use AI to help us learn about the human brain. And then the one that's closest to my own research is A. AI should augment, not replace human capabilities. It's inevitable that AI will reshape significant swaths of the global workforce, and we should be prepared for that and make sure that policymakers are prepared for potential upheaval in coming generations, and that we do not repeat some of the mistakes that we did with globalization that, again, had uneven impacts across society. But we also think that AI can be built in a way that enhances the qualities that make us human if we take an attitude of design that's based on augmentation rather than replacement. Now, because of some of the potential positive and negative social impacts, we've seen a proliferation of AI for good initiatives. You could say HAI is one such institute. And there's 2 main ways that I see these efforts going. The first type is often made up of social scientists who notice and critique the potential or real harms of AI. And that is useful, but that doesn't help us apply AI in positive ways. It might avoid some of the problems after the fact, but we'd like to get to these warnings earlier. How do we proactively design AI to avoid these issues? The second type of effort, which is both more common and often fails, is when technologists try to go it alone. So typically, AI experts see an important social impact area like education or health and apply AI naively so that it doesn't actually work well in practice. This has happened repeatedly, but has occurred acutely in short-term crises like COVID, but has also occurred repeatedly over the long term. So for example, in 2016, Turing Award winner Jeff Hinton said, "We should stop training radiologists now, as AI will easily surpass humans within 5 years." That was 8 years ago. Luckily, our medical school is still training radiologists because this has not worked out. Not in AI in radiology, not in AI in skin cancer detection, not in AI in several other areas. Often due to the differences between the ideal data sets on which these researchers train and test their algorithms and the messiness of the data and workflows found in real-world hospitals and clinics. That is not to say that these algorithms will not surpass or equal humans on certain narrow tasks, and in fact, in some of these areas, they have started to do so. I think what's more important is these researchers don't even solve the right problem. They're thinking that these jobs are just these narrow tasks when in fact they do many other tasks as part of their work. So for example, instead of trying to replace radiologists, we might want to have AI systems working in tandem with the radiologist to make this technology more useful, augment the radiologist's capabilities rather than replace them. So as my Stanford radiology and AI colleague Kurt Langlotz wrote in one of his articles that was popularized in a New York Times article, he wrote, "Will AI replace radiologists is the wrong question. Instead," he wrote, "the right answer is radiologists who use AI will replace radiologists who don't." So think about that. I think that same form of a sentence could be true for many other fields. Radiologists who use AI will replace radiologists who don't. The big problem is we don't know how to design AI systems to have positive human impacts. And I believe there is a better way to design AI for positive human impact. So this better way is what I term human-centered AI. How do we get the positive outcomes from AI? That is, what would it have taken to avoid some of the negative outcomes from a thing like Compass's AI-assisted sentencing? To avoid these outcomes, we need to design and analyze these systems at 3 levels in conjunction in terms of the user, the community, and society. And I believe that if you do, you'll create technology that has a better chance of making a positive impact. So what do I mean by these 3 levels of analysis and human-centered AI? So first, human-centered AI is about the scope of who we study, to find our problems, develop our solutions, and evaluate the resulting systems and applications that we build. To do this, we first need to have a user-centered process. So that is, integrate well-known techniques from human-computer interaction and design that account for the needs and abilities of end users of computing systems early and often, and rapidly iterate and improve a design through rigorous testing. That will help us develop AI systems that work for humans rather than to futilely try to replicate humans. But I'd claim that's not enough. AI systems have impacts on communities and societies beyond just the direct users, whether that's society, communities who are labeling training data or communities whose decisions are being made about them. So, as has been illustrated by some of the harmful examples I mentioned previously, we can't only design around the user. That would be like designing the sentencing system in Compass just for the judge, creating a nice user interface that the judge could understand the data, but that would ignore some of the underlying systemic issues. It would ignore the community that the system impacts, the people who are accused, the families, the lawyers, the victims, their families. We need to understand the issues of the different communities they come from and the structural barriers they face, for example, racism, before we can appropriately design that sentencing system. Maybe some of these people who we meet at that community-centered level of analysis would become users and should be included in our user-centered level of design, changing the definition even of who we think the system is intended for. But my claim is even that is not enough. We also need to understand what the impacts are on society at large if the system were to become more ubiquitous, as a system like Compass we see was. For the Compass system, what does it mean to have a large percentage of black males in the prison system in the US? Or a large percentage of people who are caught using illegal drugs? These are issues that have immense societal costs. And we need to be able to forecast what might happen if the software becomes ubiquitous and design to mediate the potential societal impacts. Now, you should be saying to yourself now, this sounds very hard. In fact, it is hard, but it's especially hard for computer scientists and engineers who have no training on how to think about things at these other levels of analysis. That's why you need true interdisciplinary teams working on AI systems and applications. So not only AI technologists and experts from design, but also experts from the social sciences and humanities, and domain expertise depending on the area. So experts, for example, in fields such as medicine, law, or environmental science, depending on your application. And these experts need to be true partners on AI projects from the start, rather than added near the end to investigate possible harms. As has been shown in numerous cases, whether from Meta to Google to others, simply having safety teams and trust teams later try to decide whether a system should be released is a recipe for disaster. Those systems will be released because there's too much pressure. Whereas if you have these folks on the teams early on, they have social impact on their peers that can change which decisions are made. And we've seen this in cases over and over. I want to run you through what this type of analysis might look like for an example beyond sentencing. So what does human-centered AI analysis look like for autonomous cars? Here's a Tesla with its autopilot feature. Whether now or in 10 years, autonomous cars will happen. It's just a question of how much autonomy and where it's used. Does it work on any road, anywhere, in any weather, or is it more limited? But I would claim that what most university researchers have done previously, and the reason I mention universities, this is not a new field. We've been working on autonomous cars for 40 or 50 years. And now what car companies and self-driving startups have done is primarily look primarily look at that user-centered level, i.e. the driver. So what would the driver see when in autopilot mode, here behind the steering wheel? What should it show, or how should it get the attention of the driver when the system is less sure about its inferences due to weather or due to lack of recent maps or other cars? That's at the driver level. But these other levels of analysis are also quite important to solving or even posing the problem correctly. At the community level, we care about other drivers and their behavior, whether in autonomous cars or non-autonomous cars. So in my neighborhood, autonomous cars go around, and guess what? The drivers of non-autonomous cars change their behavior when they see these cars, okay? That's something we could have learned in the research lab had we had the proper analysis rather than wait till we've deployed these things for hundreds of millions of dollars. We also care about studying interactions with pedestrian and bicyclists. This has been an afterthought for these efforts and has led to many of the problems that might have been avoided if they had been considered much earlier on in the conception of autonomous driving. You may recall one of the first deaths was a person who was pushing their bike at night across the road. So they thought about pedestrians, they thought about bicyclists, they didn't think about a pedestrian with a bike. The system failed. Somebody died for that because of that. Finally, at the society level, we need to consider the impacts of autonomous cars on a city or a region. Maybe the impacts are not as positive as the enthusiasts, who are often engineers, might lead you to believe. Some studies have shown that autonomous cars will lead to more traffic and more deaths due to driving more miles, people living further away from where they work, and sending cars around empty. These aren't just newspaper headlines. They're based on research, for example, by transportation experts at the University of Texas, who found, at least in the Texas Triangle mega region, which is Austin, Dallas, Houston, and San Antonio, autonomous cars will likely swamp traffic due to the changes that these AI-based cars will bring. So just to give you an example from my own life, I live on the Stanford campus. It's about 50 or 60 kilometers south of San Francisco. If I'm going up to the city to see a show with my family, I'm not going to pay $50 to park my car. I'm going to send it south, either back to my driveway safely, or maybe there will be some entrepreneur who will make a secure garage 10 miles south that I can park in. But that car is going to be going around empty. Or maybe I live on the Stanford campus right now, and I might decide it's not worth $3 million to live on the campus. I'll move to the beautiful California Central Valley. I'll spend a little more on electricity for AC, but I might sleep in my car 2 hours every morning on my way to work, or I might make PowerPoint slides because that's what faculty do. So, with this type of analysis from the start, we might decide our societal resources might be better spent on building a better public transit system, like what you have here in Seoul. Though I see a lot of people still in their cars. I'm amazed at the traffic with such good trains. If we only analyze and design at the user-centered level at the start, we may ignore these important questions until it's too late. These are questions of power. Who has the power to choose what we do with our societal resources? And right now, that power is concentrated. In engineering, we usually, when we talk about power, we're talking about electricity and chips and things like this. But I mean social power. And in this case, it's big car companies and tech companies that have that power. And in the case of foundation models, it's in the hand of a few tech companies. And that power is really important, as has been highlighted in some of the talks yesterday. That power includes cultural power. The cultural values that are embedded in those values aren't necessarily good or bad, but they may not be appropriate for different societies. So here in South Korea, we might want different values embedded in these models than in the models that are mainly trained on North American and Western European data. And that's an important question how to resolve. Now, there's no silver bullet in ensuring that the AI systems and applications that are created do not have negative impacts. But there are 3 approaches that we can take that will help increase our chance for ensuring responsible AI. First, as I've advocated for in this talk, design. Having an appropriate design process that goes beyond traditional user-centered design to consider community and societal impacts, and does this with diverse interdisciplinary teams. I think this is a really key idea and is one that we're working on in our research at Stanford and with some of our corporate partners who are trying this in their own work. Second is really about education. So embed ethical thinking directly into the specific courses where these lessons can have impact. So for example, learning about ethical issues and paying crowd workers to label training data when learning about NLP, or when learning about human-computer interaction and design, understanding the ethical implications of who you leave out when you go to do your user interviews and decide who to involve in a design. There are ethical questions about that, and that's what we teach with the help of our embedded ethics program. Others after me, Mayron and Kathleen, will speak more about what we've done at Stanford based on earlier work led by Barbara Gross at Harvard. But these first two approaches won't catch everything. There will be people who only care about making money. I assume that guy who sucked up everyone's photo on Facebook and then sold it essentially to intelligence and police agencies all over the world is mainly focused on money, though somebody questioned me on that. I haven't yet learned the real answer, but seems like a profit motive to me. Or those who make mistakes simply due to negligence. That's where really the third approach comes in, policy. Whether it's regulations on AI or new laws, sometimes there needs to be legal and financial consequences to limit some of the potential harms. Stanford HAI is working on all of these approaches to ensuring responsible AI. Again, HAI's mission is to accomplish this through research, education, and policy. HAI has had numerous accomplishments over the last 5 years that we've existed. In particular, we've helped shape the global conversation about the governance of AI through direct engagement and briefings, such as our co-director, Fei-Fei Li, and Associate Director, Rob Reich's meeting with President Biden last year, calling for the federal government to adopt a moonshot mentality, which President Biden then picked up in his own speeches about this, towards AI public sector investment, and educational programs like our Congressional Boot Camp that's going to be happening again the first week of August, where we bring in congressional staffers and teach them about AI, since these are the people who are actually going to be writing the legislation. Stanford's played a leading role in ensuring AI is being steered in a human-centered way through these efforts. Moreover, we've been bold and visionary with ideas like the National AI Research Resource, the NAIR, which is really an AI research computational cloud that President Biden stood up a pilot for most recently, and a bipartisan bill exists in Congress to solidify and fund this. Currently, we have 3 key research initiatives and centers at HAI. So the Digital Economy Lab, which is now a world-class research arm studying the impact of AI on the future of work and society. The AI Index, which is a leading measurement of AI that is a resource worldwide, which we saw some slides from the AI Index and others' talks here yesterday. And then we've also created the Center for Research on Foundation Models, where we not only coined the term foundation model, but we regularly contribute to leading scholarship in the technical development of AI and understanding the impact of foundation models as society adopts them, as well as benchmarking these foundation models against different things we care about, for example, bias or compliance with the upcoming regulations. Most importantly, as a research university, research is core to our mission. We have funded over 380 faculty at Stanford through our grants programs. The connections here in these graphs represent collaborations between faculty, and the colors represent all of Stanford's 7 schools. And the connections that you can see here are interdisciplinary, so different colors going together. And that's been a really key thing that we've done over the last 5 years, is encourage this kind of interdisciplinary research. Funding, as it turns out, is a great incentive for faculty to embark on this interdisciplinary work, and these grant programs have made a large impact for the Stanford faculty. We're also the first university to develop a process that goes beyond the traditional institutional review board, or IRB, and looks at the potential societal impacts of our research. So all HAI-funded research must pass through our unique ethics and society review process. And the faculty have indicated to us they believe it makes their research better. You can read a PNAS journal article about that process. But there is a challenge that is facing academic AI, as a lot of the key research on large AI models is leaving academic AI behind. There are a few major reasons for this, but an important one is the amount of compute used to build significant AI machine learning systems has increased exponentially over the last 10 years to over 1 billion petaflops today. The growing demand for compute in AI carries several implications. Most importantly, industrial players tend to have easier access to computational resources than others, such as universities. As you all well know, at the end of 2022, ChatGPT was released, waking the general public up to what has been going on for almost 10 years in terms of this increase of computation and in this increased power of AI models. ChatGPT was trained on approximately 10,000 GPUs over several weeks. Stanford's top AI groups altogether have low 100s of modern GPUs. Okay, this just gives you an idea of what's going on in the gap of computation between universities and industry. Now, it's not that we want to compete with industry. That's a fool's errand in this. But we need to have the infrastructure and the resources to do research at the scale where the important phenomena are occurring, right? You don't see some of these things that happen in large foundation models until you're at a certain scale to see what's going on. And it's also important that academia continue to play a role in AI research, especially in foundation models, because these models will be the underpinning of many societal scale systems and applications. And this type of AI will be key to providing an opportunity to address big questions, such as curing cancer, to understanding what human intelligence truly is. But to address these questions, we need team science that requires big resources and moves at a Silicon Valley pace. This does not work under current academic structures. Team science needs large interdisciplinary teams of PhD-level researchers who have the skills to work on large models, but also software engineers that can build these infrastructures, data scientists and designers, domain expertise, as well as other experts. These problems are data and compute-centered. You need the computing infrastructure to even start to tackle these problems. Finally, these fields are moving very fast, AI especially. You need the agility to keep up. However, within the traditional academic model, we face constraints in truly accelerating this type of team science work. Our solution to these problems at Stanford, as well as the opportunities of team science, is what we call HAI Labs. So our goal is to establish a new academic model in AI with the mindset of the university. So the focus is on positively impacting society using the breadth and the interdisciplinary expertise that academy brings that you will not see in industry. And we want to bring that expertise to bear and provide the appropriate computation, data, and talent to do so. We'll be sharing more on our plans for this over the next few months, but this initiative is something that may involve international collaboration. So for example, with leading universities and companies here in Korea and elsewhere in the world. What I want you to take away from this introduction is that there are many great applications where we can use AI to help people be better at their tasks, to augment them to be better learners, better designers, or take better care of their body. The key is to keep users, communities, and society's needs at the center of these smart interface designs. It's critical that we design at these three levels. We're in the really early days of finding the right design processes to practice truly human-centered AI. But if you just start by designing with communities beyond your direct user population, you will create AI systems that are more likely to have a positive societal impact. We also need a new approach to academic AI research. HAI Labs will offer the ability to practice team science at the scale needed to have positive impact on society. Thank you.